Section 2.2, Factoring Whole Numbers. You will need to be proficient at doing two different skills in this section. First, finding the prime factorization of a number, and second, finding the greatest common factor for a group of numbers. So let's work on the first skill. Prime factorization means writing a composite number as a product of prime numbers. So let's do an example. Let's say that you had the composite number 18. What are two numbers that you can multiply together to get 18, one of them not being the factor of 1? Well, I could multiply 3 times 6. And what I'm going to do is I'm going to write it down kind of like a factor tree, which maybe you've seen before. So I know 3 times 6 are factors of 18. Are either one of those numbers prime? Yes, 3's a prime number, and it's prime because there are only two factors for the number 3, 1 and 3, so I'm going to circle it. 6 is a composite number still, so I need to break that one down again. 6 could be written as 2 times 3. Now both 2 and 3 are prime numbers, so I am going to circle them. Prime factorization means writing a composite number as a product of prime numbers, and now everything that I have circled, if I multiply all three of those numbers together, I do get 18, and all of those are prime numbers. So the prime factorization of 18 is 2 times 3 times 3. Now I want to do the same problem, but I want to just do it a little bit differently. Remember I said to start off with you just need two factors of that number, and I chose 3 and 6. Well, I could have chosen 2 times 9. So if I choose 2 times 9, once again, 2 is a prime number, so I'm going to circle it. 9 is not a prime number, so I'm going to factor it, and I'm going to have 3 times 3. Well, the 3's once again are prime numbers, and you'll notice that I get exactly the same answer, 2 times 3 times 3, for the prime factorization of 18. In other words, it doesn't matter how you break down the number to start with. In the end, you're going to get the same answer. Let's do another example, 132. I want to think of two numbers I can multiply together to get 132. And since 132 is an even number, I know I could do 2 times something. But it always works out better to try to choose a bigger number if possible, or the biggest factor that you can think of easily. And I'm taking a look at 132 and I'm saying, hey, I know that's also divisible by 6 because it's an even number, and it's also divisible by 3 because the sum of the digits is equal to 6. So I'm going to start off by multiplying 6 times something. Now I'm not sure what it is, 6 times whatever, so I'm going to do a little bit of math. I'm just going to do the regular algorithm over here. 6 goes into 13 twice. Subtract, I get 1, bring down the 2. 6 goes into 12 twice again. So the other factor with 6 is 22, so I have 6 times 22. Now neither one of those is a prime number, so I'm going to break them down again. 6 I'm going to break down as 2 times 3. 22 I'm going to break down as 2 times 11. Well, all of those numbers now are prime numbers, 2, 3, 2, and 11. So I do have my final answer. Usually the final answer is written with the factors in order from greatest to least, or from least to greatest. So I'm going to rewrite my answer as 2 times 2 times 3 times 11. Let's do one more, an even bigger number. Let's do 400. And once again, using my divisibility rules, I know that 10 is a factor of 400. So I could right away multiply 10 times something, and it would be 10 times 40. Now, I could have used other numbers. I know that 20 times 20 is also equal to 400, but I wanted to use one of the divisibility rules we talked about earlier, so I did the 10 times 40. Neither one of those are prime numbers, so I'm going to break them down. 10 is 2 times 5. And right away, those are prime numbers. For 40, I'm trying to think of two numbers I can multiply together to get 40. And I could choose all sorts of different answers, but I'm going to choose 5 times 8. Now, I know 5, once again, is a prime number, so I'm going to circle that. 8 is not a prime number, so I'm going to continue to break that down. I have 4 times 2. 2 is a prime number. And finally, 4 needs to be broken down one more time as 2 times 2. Now, everything that I have circled, if I multiply all those circled numbers together, I'm going to get 400. So this is the prime factorization of 400. And I could write that as 2 times 2 times 2 times 2, because there are 4 2's, times 5 times 5. So that is one way I could write it. Now I also want to mention, you don't have to do this, but you could also write this using exponents if you wanted to. I have 4 2's, so it's really 2 to the 4th power, and I have 2 5's times 5 to the 2nd power. You could also write it that way. It doesn't matter to me which way you write the final answer. The second objective in this section is to find the greatest common factor of a group of numbers. What is the greatest common factor? It is the largest number that divides each of the given numbers exactly. Let me give you an example. Let's say that you were given the numbers 12 and 16. Well, what are all the factors of 12 and what are all the factors of 16? Well, in order to get 12, I could multiply 1 times 12. I could multiply 2 times 6. I could multiply 3 times 4. Those are all the factors of 12. And if I wanted to, I could write them in a list from the smallest to the greatest. 1, 2, 3, 4, 6, and 12. What are all the factors of 16? Well, all the factors of 16 are 1 times 16, 2 times 8, and 4 times 4. And once again, if I wanted to, I could write all those numbers in order from the smallest to the greatest. And I would have 1, 2, 4. I'm not going to repeat the second 4, 8, and 16. What's the greatest common factor? What's the largest number in both of those lists? Well, I take a look at that and I see 4 is the largest number in both of those lists. So we would say that the greatest common factor of those two numbers is 4. There is another way to find the greatest common factor of two numbers, and it will not matter to me which method you choose, but let me show you this second method. Let's say I wanted to find the greatest common factor of 20 and 30. I could, if I want to, first of all, break both of these numbers into prime factorization form. So the 20 I could multiply as 4 times 5. Since the 5 is a prime number, I'm going to circle it. The 4 I could multiply 2 times 2, and 2 is a prime number, so the prime factored form of 20 is 2 times 2 times 5. I could do the same thing with 30. I'm going to multiply that, first of all, by 5 times 6. And 5 is a prime number, so I'm going to circle it. 6 I could break down as 2 times 3, and both of those are prime numbers. So the prime factorization of 30 is 2 times 3 times 5. Well, what do both of those prime factorizations have in common? Well, they both have 1 2 in them, so I'm going to write down a 2. They also both have a 5 in them, so I'm going to write down a 5. If I do that and then multiply what they both have in common, 2 times 5 gives me 10. 10 is the greatest common factor of these two numbers. As I said, it doesn't matter to me which method you choose, either writing out all the factors or using this prime factorization method. Sometimes you miss a factor if you just write them all out, which makes it a little bit more difficult. And oftentimes people find more success in making sure they have the correct answer by using this method of first breaking things down into prime factor form. Let's do one more example, and I will do it both ways. Let's say I wanted to find the greatest common factor of 28 and 42, and I'm going to do it using the prime factorization method. So I see the number 28, and I am going to break down 28 however I can. I know that 4 times 7 is equal to 28. 7 is a prime number, so I'm going to circle it. 4 is 2 times 2, so I'm going to circle both of those. So the prime factorization of 28 is 2 times 2 times 7. If I do 42, I know that 6 times 7 is equal to 42, and once again 7 is a prime number. 6 could be broken down as 2 times 3, which are both prime. So I have 2 times 3 times 7 is the prime factor form. What do they both have in common? Well, in common, they both have a 2, so I'm going to bring down a 2. They also both have a 7, so I'm going to bring down a 7. And then I'm going to multiply. 2 times 7 gives me 14, so the greatest common factor of those two numbers is 14. If I chose to do it the other way, I would need to write down all the factors of 28. So writing down the factors of 28, I'm going to have 1 and 28. You can see I'm going to do it. I'm going to try to write these numbers in order from smallest to greatest. So I know 1's the smallest and 28 is the largest. I'm trying to think of what other numbers I could multiply together to get 28. And I know, using divisibility rules, because 28 is an even number, I know 2 times something has to equal 28, and it would be 2 times 14. I also know that 4 times 7 gives me 28. So now I have written all the factors of 28. Once again, sometimes the problem with this is if you miss a pair of factors, it could cause problems for finding the greatest common factor. For 42, I'm going to do exactly the same thing. I know that 1 times 42 is equal to 42. And I also know that 2 times something is going to give me 42 because 2 is an even number, 21. Now, I need to see if there's any other factors. Well, 42, the sum of 4 and 2 is 6, so I know it's divisible by 3. So I know that 3 times something has to give me 42. And 3 times 14 would give me 42 as I go through. Finally, I also know from my facts 6 times 7 is equal to 42. So I'm going to put in 6 and 7. Notice I have a lot of factors for 42, but the greatest common factor is 14. Either way, you're going to get 14, and once again, it won't matter which way you go through and do it, as long as you are able to get the correct answer. And it would be, as I said previously, being able to find the factors of numbers is very important, especially when working with fractions. Please be sure to ask me questions if you have any. Thank you.